means we talked about properties of real numbers, real number sets. I just want to look at kind of some operation stuff today. So just remind you very quickly about order of operations. So real quick, it's been a little while. Remind me, how would we deal with subtraction of fractions? What would I have to do there? I need a common denominator, right? So what does that look like? We'll come back to this stuff later again too, but what would my common denominator be? 10, okay, how come? What's your thinking there? How do you arrive on 10? Why? Say it again. 5's a factor of 10, and 10's a factor of 10, isn't it, right? So it's the least common denominator is the least common multiple of the denominators, right? In other words, a way to think about that is it's the smallest number that they would both divide into evenly, right? Does that make sense? And we'll come back and look at that in more detail later. But then how would I accomplish that again? I know this is not high level stuff. You know how to, but we're just going to kind of still ease into things a little bit. I mean, it's the start of the school year. What are the steps I would take? What would I do? Multiply. Okay, I'm going to multiply the first fraction by 2 over 2, right? And we'll talk more about this too. Why is that? What is 2 over 2? 1. Aha. Multiplying by 1. Does that change the value of the fraction? No, it doesn't, right? 1 is it's our multiplicative identity. It's the special identity number for multiplication. I can multiply something by 1 and retain the value. All I'm doing is changing the look, right? And we'll come back and talk more about that later. But yeah, I'm just going to multiply both the top and the bottom by 2. And what's that going to give me then? I'm going to get 6 tenths minus 9 tenths, which is how many tenths? There you go, negative 3 tenths. Where would the negative sign go for a fraction? Which one? Where? Say it again. Either where? In front or in the numerator. Where should it probably not go? The denominator. Yeah, there you go. Good. Okay, so what about the next option? What's that equal to? Negative 25, isn't it? Right. It's not positive 25. It's negative 25. How about the next option? Is positive 25. Okay. Good. And why is that? How come the top one is negative and the bottom one is positive? Okay, yeah, it has to do with, is the negative included in the exponentiation or not? In the bottom one, it obviously is, because when you have a quantity taken to a power, that implies that everything inside the quantity, the parentheses, is being taken to that power. In the first case, the negative is not. How come? Why is that? If you had to explain, you're right. Your intuition is absolutely right here. But if you had to explain to somebody why is the negative not included in that exponentiation there? Right. Okay. Why though? Are there some rules that you followed there subconsciously? Maybe in order to what you were doing? Order of those operations you were applying? Ah, okay, but so by order of operations, remind me how that works. What comes first? Oh, okay, so exponents come before multiplication. Right, okay. And so the negative in front of the 5, that's actually just a coefficient. It's really the equivalent of multiplying negative 1 times 5, right? So we don't multiply the negative by the 5 until after we've taken the 5 to the power of 2. Does that make sense? We don't multiply that negative exponent until after we've done that exponentiation. Good. Okay, how about something like that guy right there? this one? So it's going to be negative or positive, first of all? It's going to be negative, right? Now let's just think about why that is. A negative number to an even power is always positive. A negative number to an odd power is negative. If I take a fraction to a power, what am I effectively doing? And we'll review all this stuff later in the year when we get to, pretty soon, when we get to polynomials, we'll go through and rigorously review all the properties of exponents. But just kind of to get us up to speed for the year, what's your thinking on this? What do I have to do to both parts of that fraction? In other words, help me out with this property. If I have the quantity A over B to the n power, what's that equal to? A to the n over B to the n, yeah. So we're kind of, it's almost as though we are distributing that exponent to both parts of that quotient, right? Good. So we end up then with negative 1 cubed over 4 cubed, which is what? Negative 1/64. Good. Okay. All right. How about this stuff? Let's take a quick look here. Which of these is the best answer, A or B? Is it a real number or not a real number? In other words, can we do this? Is there going to be an answer, or is it going to be one where there's no solution? There is an answer. Yeah, good. And so we know it's A is the option we're going to choose, not B. What does that simplify to? 5 over 12? Negative 5 over 12? Okay, good. Okay, again, we're just going to split that. And what's our thinking here? If we take a square root, any kind of root for that matter, but just square root in this case, a square root of a quotient, the first thing we do is we're going to split that into separate square roots on the top and the bottom. Again, we'll review all this stuff later. How about this one? What's the best option, A or B? B. How come? What's our rule here? Okay, for real numbers, you can't take an even root, so in this case a square root. You can't take a square root of a negative number. What's our other rule for real numbers? You can't divide by 0. Okay, those are the two really important rules that we'll come back to again and again and again. How about this one, A or B? A, good. And what is the 4th root of 16? The 4th root of 16. It's 2. Yeah, good. How come? Because say it again. 4 squared is 16. Okay, let's go one step further than that. Okay. 2 to the 4th is 16. Okay, make sense? Okay. All right. So yeah, let's let's quickly just review order of operations. You guys all know this. Did you learn PEMDAS or GEMDAS? PEMDAS. That could also be a G for grouping. It doesn't, I don't care. It doesn't make any difference. What do we mean by this? Order of operations. So the first step is we're always going to simplify stuff inside parentheses or any other grouping symbol, right? What are some other things that could group stuff together in math? Brackets could. We could have layers of parentheses where we have parentheses and brackets. Just a quick note on that. When you're doing your problems in my math lab, you can't use brackets. You just have to use nested parentheses. It won't see brackets. It reserves for something else. So just FYI. What else though? What are some other things that maybe aren't so obvious, but there's implied grouping? So absolute value bars, sure. What else? Anything else that would cause you, in order of operations to have to, first of all, simplify some things that are grouped. Other ideas? When would that apply? Parentheses are obvious. Some things aren't so obvious. What if I had something like this? What if I were doing something like, oh goodness, that's what what's the first thing you would do there? You'd add 2 and 14. Okay, so those must have been grouped somehow. How are they grouped? Okay, because they're inside a function. They're inside the square root function, aren't they? So anytime you have stuff that's inside of some function or operation, then you have to do that first. In other situations later in your career, you guys haven't probably seen a lot of this, but if you had something like a trig function, the sine of, x plus 2x over 3, well then we would combine the terms inside the sine function also, right? Those are grouped, okay? So first is the grouping symbol stuff. Parentheses, brackets, nested parentheses, inside functions. The other thing would be fraction bars, right? Anytime we have a great big fraction, we always want to write our fractions with fraction bars. If there's a bunch of stuff going on in the numerator and a bunch of stuff going on in the denominator, remember there are always implied parentheses around the entire numerator and the entire denominator. So we're always going to want to simplify everything on top. That's all grouped together, everything on the bottom, and then we'll actually simplify that quotient. Okay, after parentheses, what's next? E for exponents, right? So what do exponents include? Obviously exponents. What else sneaks in there for exponents? Okay, roots or radicals, right? Anytime we have a radical or any kind of a root, and we'll talk later in the year why that's the case, but those also count as exponents. Then we get multiplication and division. Oops. What about multiplication and division? Which one comes first? Whichever one comes. What do you mean by that? Whichever one comes first. Going in which direction? Okay, it's going from left to right. Whichever one of those two operations we see first comes first. In other words, the M and the D are on equal footing, right? That's why we write them horizontally instead of vertically. And then the same with addition and subtraction last. Good. So you guys know all this stuff. I know you do. So let's just practice a little bit. Take a second, think that one over. See if you can tell me what the answer is. What do you think, everybody? 100. It's 100, isn't it, right? It's not 1. Good. And why is that? Because the first operation is going to be division. Yep. So we get 20 divided by 2 times 10 equals 10 times 10, which is 100. Good. No big deal. What about something like that? What am I doing first? Yeah, so inside the parentheses, 1 minus 4 gives us -3. What's next? Exponentiation. Okay, so what's that going to give me? It's going to give me a 9 there, isn't it? Yeah. -3 squared is 9. Now, what's next? Multiplication. 2 times 9 is 18. And then finally we get 19. Piece of cake. All right. So, yeah, notice, here's what I would sort of think it's wise to do when you're doing your work is always write a PEMDAS tree. And when we're simplifying, we're always going top down. Right, just get used to that. So we want to simplify numerator and denominator separately. So if I have something like this, then I'm going to take care of that entire numerator first. So everything up there, we're going to deal with separately from everything down there. Okay, what's the first step in the numerator? Absolute value. What is the absolute value of negative 2? 2. Okay, good. What about on the bottom, first step? Square root. Okay. What's next on the top? Exponent. Good. What's next on the bottom? Subtraction, right? So the bottom's going to be done. Top, we got to keep going a little bit. Okay. Next on the top, I'm obviously adding. I'm going to get 9 over negative 9, which is negative 1. And we got it. Perfect. Okay. Yikes. Lots going on there. Okay, what's first? Say it again. Yes, okay, good, because we're inside, I've got grouped nested parentheses. Those are the inside parentheses. Inside those, the first thing I see is this absolute value. Good, so the absolute value of negative 6 plus 2 is what? 4, because I'm going to get a negative 4 inside. This is going to turn it positive. What's next on the top? Yeah, square root. 8, I got to work inside. 8 plus 1 is 9. What's the square root of 9? 3. Good. So on the top then, I've got 15 minus what? 7. And then that whole thing is being squared, right? Okay, how about the bottom? Exponent, good. So I'm getting 3 minus, what's 3 cubed? 27. Good. On the top, what's that giving me? 64, because I'm just getting 8 squared. Good. And on the bottom? Negative 24. Okay, so I'm getting 64 over 24, and let's move that negative sign out front. Okay, we done? Is that simplified? What else could we do? Say it again. Yeah, okay, good. The greatest common factor of 64 and 24 is 8, right? So I could divide both the top and the bottom by 8, which is giving me, yeah, good. So I end up with negative 8/3. Very good. Okay. So what are we doing here? This looks a little different. It says evaluate the expression when x equals 8 and y equals negative 3. Yeah, right? Evaluating just means plugging values in and simplifying. So this is just what I would call a plug and chug problem. We're just going to plug in these values, and then from there we're just going to simplify using order of operations. So to get that guy and that guy, and what's that give us? We're going to get 4 plus 2 times the absolute value of 8 minus negative 3 divided by 8, good, plus 2 times, okay, good. So whenever you are evaluating, I think it's a good idea to, when you're plugging in values, to enclose them in parentheses. For some obvious reasons. If you don't do that, for like right here in this top example, if I didn't put those in parentheses, it looks a little bit goofy, doesn't it? We really, in math, we don't like to do things like this, minus, negative, right, without enclosing something in parentheses. That looks a little strange. It's easy to make mistakes interpreting that. If it's in parentheses, it's much easier, especially when you're multiplying also. If I didn't include those parentheses, this would have looked like that. Okay, that looks like subtraction, right, instead of multiplication. So we always want to include those values we're substituting in parentheses. All right, on top, real quick, I know this probably, you guys are taking too long probably here. 4 plus 2 times the absolute value of 11. What is the absolute value of 11? 11. So we'll just go there. We'll just write 11 here. How about it? On the bottom, 8 plus negative 6, that's the same as 8 minus 6. Good. So do a little mental math. What do we get on top? Say it again. What's 26? Good. Over which is? Very good. Okay. All right. So they give us an expression here, 5 times the quantity x minus 32 divided by 9, and that represents the equivalent temperature in degrees Celsius when x is the temperature in degrees Fahrenheit. Okay, so what are we doing when we complete this table? Like, what am I doing with the negative 4 here? I'm just substituting, aren't I? Okay. I want to show you a little technology trick here. So when you're doing repeated substitution, this is a great use of technology. So do you guys know how to, I don't have my TI-84 emulator set up yet. We'll come back and look at this stuff on the TI-84s, and I'll remind you how to do it there. But let's just look at this in Desmos. Really like you to become experts at Desmos. It's such a good tool. How could I use Desmos to do this really efficiently? And we could even use Desmos Scientific. On the tests, I'm going to carefully control which Desmos calculator you get. And most of the time on tests, you won't get the Desmos graphing calculator. You'll just get the scientific. But you can do a lot with the scientific calculator. Does anybody know how I could do substitution really efficiently with the Desmos scientific calculator? What could I do? Okay, so I could just substitute values. Like I could do something like this. I assume this is what you're saying. I could do 5 times the quantity, and I could plug in negative 4 for x. I'd probably want to put it in parentheses, negative 4 minus 32. And then rather than having to always use this button that's the fraction button, what's easier to do, what's more efficient, is just to highlight what's going to be in the numerator and hit the division symbol, and it automatically creates a fraction, okay, divided by 9. And it gives me a simplified answer. Okay, what would I have to do for 10 then? Just go up and change that to a 10. Does that make sense? Okay, that works. I got a better way for you. Got a better way. What if we set this up as a function instead? So x is the input, right? So I'm just going to call this f of x, where x is the input for my function. And I'm going to write it exactly as it's shown, with an input variable x. So 5 times the quantity x minus 32. I'm going to put all that stuff in the numerator and divide it by 9. Okay, doesn't give me an output. But now what am I able to do here that's pretty handy? Okay, now I've defined the function, so I can go in and put values into the function many times as I want to. Look at that. There's f of negative 4. There's f of 10. And there's f of 32. See how easy that is? That's a great way to do it. Define a function, and then you can input values as many times as you want to. What if it asks for an exact answer? So it does, like I don't want to put in a decimal. What could I do to that second answer? Yes. Okay, whenever, this is one really nice thing that Desmos does. Desmos recognizes when an answer is a rational number, and it gives you the option of writing it as a fraction as an exact answer. So in a math situation, if a question on one of my tests or assignments or on an SAT test or something, if they're asking for an exact answer, are decimals ever okay? Sometimes. When would a decimal be okay? When would it be exact? When it terminates, right? A terminating decimal is an exact answer. But a repeating decimal would not be okay, or if it's irrational, we'll talk about that later. But if it's a repeating decimal and it's rational then, right? But we'd want to write it as a fraction because that is exact. Is 1/3 really equal to 0.3333? It's really not, is it? Right? It's equal to 1/3. If I wanted to write that fraction exactly, I would have to include an infinite number of threes, and that takes a while to write. So we just write it as a fraction. Okay, I'll show you something else that's kind of nice here. A little technology piece. If we go to Desmos graphing, I can do something similar. I can define the function f of x equals 5 times the quantity x minus 32 divided by 9. And what if I want to put in a whole bunch of values? Well, there's a really good option here. I can click on the gear and look at that little table option right there. That's pretty good. If I create a table, then it's giving me the opportunity to put in a whole bunch of input values and just create the output values in the context of a table. So now I could just do something like this. I could go -4, there's the output for -4. I could go 10, there's the output for 10. And I could go 32, and there's the output for 32. The one disadvantage of that is I don't think it gives you the option when you're in a table, and you tell me if you figure out a way to write those as fractions. I don't think that's an option. Okay? And, that's just more of the same. I think I'm just going to call it quits here. Let you guys get to work on this. Go for it. Grab your Chromebook.